Are we ready to get started? I was a little worried tonight when I got here. Well, before I got here, because I signed up to help host this event. My role is insignificant compared to so many others, but I look at Google Maps and I say I'm going to 101 Spear Street, Salesforce, and Google is a little ahead of their time. They have already said this building is permanently closed. I don't know why. Maybe there's some plans. You never know. Anyway, so my name is John Pampwich. I'm an engineering manager at CloudBees. We develop and offer Jenkins as a commercial product. And tonight, we have a couple of speakers. I'm going to introduce Matt Stephenson, who's an engineer on my team. He is helping us build out what we call Private SaaS Edition. It's a tool to help you scale Jenkins across enormous workloads, literally hundreds of thousands of executors if you wanted. And then after Matt, Matt will introduce Vaishali, and we'll have Andre after that. So Matt, come on up. Oh, and thanks to Salesforce for hosting us.
Awesome. Good evening. I'm Matt Stephenson, the software engineer at CloudBees, and I'm going to talk this evening about using Docker with pipelines because it's good. I do have to credit these slides to Tyler. I didn't make them. He made them, and I'm taking over his presentation this evening because he couldn't make it. So why use Docker for doing builds? It gives you, was anyone here using Docker for their build environments? Yeah, plenty of people. It gives you a lot of isolation, keeps you from messing up your, like retaining some level of state in your build agents, in your build workspaces. Gives you a fresh, clean build, and it'll give you, it'll make it actually a little bit quicker for, because of the layers and the union file system in Docker, with getting new environments spun up, the new build environment set up. So I'd like to go over just a few useful Docker images just for getting things set up. There's a lot more out there. There's OpenJDK, Maven is a Docker image, Go, if you're building Go, anything in Go, there's a Golang container that's really nice, image really nice, Ruby, Python containers, and of course you can always just go to Docker Hub, search for any containers you might be interested in, and you start looking at running different versions of Golang. You can utilize different tags on those containers. So now we're going to look at using Docker. We're going to start looking at pipeline a little bit, some of the benefits that you get by using Docker. And we're going to build a simple Java app. And if you'd like to follow along at home, all you need is a Jenkins master. You need the CloudBees Docker pipeline plugin. You need a Jenkins agent running as root with Docker. You can run it on the same machine, but it's kind of a security hole. So I have that running on a separate EC2 instance. And then I have a little sample GitHub repository. So if anyone wants to look those up, go for it. So what we're going to look at is a couple iterations of a Jenkins file within this version control. And let me just pull up a GitHub repository. And here's the Jenkins file. So we're going to go through this. And in order to demonstrate this working, we're just going to create a new multi-branch pipeline job. We're going to point it just over at this repository. Don't really need to set anything else here. Save it. the multi-branch indexing, multi-branch pipeline jobs. It'll create a separate job per branch on this project. I have separate branches for each of the different iterations we're going to look at. Let's look at the demo itself. Now I have some jobs running. They're running on my Docker agent over here, which you can see. I'm not going to see it quite yet because we're waiting for iteration. Oh, 1 or 2 are running. Yeah.
For the current executor, the hosting the executor, are they running on master or a separate machine?
So the pipeline job, the overall pipeline job runs on the master, but the individual build steps within the pipeline job are running inside of the master running here. And I'll get back to this later, but that's our Docker containers running. All right, so let's take a look at some of the results from this and go back to our slide. So this first iteration that we're going to look at, once these jobs are done running, is what it looks like to just do a basic pipeline job where we're checking out the software from version control. We're running a Maven clean install on it, and then we're going to expose the all of the test results. That would be this. And it looks like we have an error here. Let's see what's going on. And, well, that's a bummer. We don't have Maven installed on this build agent. So now we got to like contact someone and get them to go fix that for us. I mean, I could fix it myself, but I'm lazy as a software engineer sometimes. So what do we need on this thing? We need to have a JDK. We have to have Maven on it. We have to have the path and maybe even Maven options set for the agent before it can actually successfully run Maven builds for us, build our Java stuff, build our projects. And there could be a multitude of other requirements that you have on the individual agent itself, which kind of make the agent like a little puppy dog that you have to pet at night, take care of, feed, water. So let's take a look at something that's a little bit more sophisticated that kind of removes some of our needs to take care of these build agents. So this is a pipeline job that'll check out the version control, and then it'll set 2 environment variables for Java home and the Maven path. And then it'll also, or it'll set path and Maven to looking up the individual installed JDK and Maven 3 within using the Jenkins tool installation. Let's take a look at what that looks like. It looks like that one succeeded, which is great. And as we can see, it automatically installed the JDK for us and automatically got Maven installed, ran our build, and everything's great. It took a little while to do that. It took 45 seconds to do that. And in order to make that work, before I even came here, I had to use my administrative powers within Jenkins and add global tool configurations to the JDK itself, JDK8, which is referenced here. So you see that line within Java Home tool JDK8. That JDK8 right there is the same as this. So somebody, whoever is administering Jenkins, you have to bug them and get them to add that in there. You also have to add Maven in there. And then, you know, these names could be, you could like want to install like 8 different versions of Maven, and then you're colliding on your namespace with like Maven 2, Maven 3. Now you have to have Maven 3.3.9. So it gets kind of confusing over time maintaining these global tool configurations. And you also have a lot of like, you still have a lot of state on the build host itself because these tools are installed. These are binary binaries that are downloaded and installed within the Jenkins directory that's on, within the Jenkins home, essentially, that's on the agent. It's not a Jenkins home, though. It's just the agent workspace. And so you still have a lot of like state preserved on that machine. But it looks like everything worked. We didn't have to do anything special on the server itself. We needed the JDK8 Maven on there. We had to know the names of the tools that were configured. So like if I didn't have access to manage Jenkins, I wouldn't be able to just look those names up. I'd have to know what they are. And then to add new tools, it's kind of annoying. You got to bug the Jenkins admin. So let's take a look at what it looks like to do a pipeline build using Docker. Now what we're going to do is we're going to check out version control. We're going to do, we're going to reference a Docker image. And within that container that gets started up by Docker using that image, we're going to do a Maven clean install, and then we're going to expose our test results. Let's take a look at this. So what we see is that we get started, we realize, Docker realizes that image doesn't exist, so it has to grab it, grabs it off the internet, pulls down the world with Maven, which you didn't quite see that in iteration 1 because it didn't get rid of the M2 directory on that server before the last time I tried it. But this would have occurred the first time you tried it on the other job too. The only problem is that on that job, let's say someone does, since you're sharing the M2 directory for subsequent builds, your snapshots will be preserved over subsequent builds. You might end up with some weird side effects because you're sharing that M2 directory. So go along. We got everything installed, Maven downloaded the whole world, and then we finally succeeded in our build. Now, going back one level, this build took 1 minute and 11 seconds for iteration 2 for using Docker. Let's just start that back up and start up iteration 1 again. Let's see how long they both take. All the requirements we had on this host, on this agent, was that it was running a Docker daemon and we had root on it so that we could control Docker. So it's a lot simpler than trying to deal with these very particularly, hand-rolled machines, or even machines that were kind of hand-rolling through the use of Jenkins. Let's see, how quick did those complete? 26 seconds for iteration 1 and 32 seconds for iteration 2. Maybe it's just that I'm running it on a micro. Usually Docker's a little bit quicker. That's pretty much all I got. Any questions? Does anyone want to see anything else within the Jenkins I was demoing, like more configuration? Anything that you saw like I glazed over?
So in the Docker version, the M2 settings is getting repopulated every time?
Yes.
Is that correct? So what is your opinion of that? Do you think that's good or bad? Because obviously it affects build speed, but you have a clean workspace every time.
I think that in some cases it's good, in some cases it's bad. There's like a really good middle ground that some people are exploring and that we've kind of explored internally at CloudBees, which is where you get the it's a question of like almost like I/O performance to see which one's faster, but having a Nexus mirror really, really close to where you're running your builds will reduce the I/O performance, like all of the cost of downloading all of the artifacts into the container. The alternative to that, if you don't want to do that, is to roll a Docker image that has your M2 embedded in it. And then so you can reference that on your builds. But that kind of requires running your own Docker repository. So I don't know which is more work, really. It sounds like Nexus is probably easier than running your own Docker repository and keeping images with like a mostly up-to-date .m2 directory in it.
And in the DSL there, you had the docker.image. Does that allow you to map in directories? Is there a syntax for that?
I would need to get back to you on that. There's some documentation around it. I do believe there's a way to map volumes into it, or if there isn't now, then it's probably being worked on. But yeah, that's exactly.
Thank you.
Yeah.
Yeah. I mean, just to add color to that last comment, I mean, one thing we found is for simple projects, the build times might like triple when you have to. I see it as a Maven issue because all those dependencies come in serially. Like if you've got even a simple project that has lots of dependencies and lots of plugins, it literally has to wait for the IO round trip. So to your point, like getting something really, really close. I mean, I don't know, we're running an AWS in the same AZ or region, and it's really slow. Like we've experimented with either using like EFS or some sort of like NFS solution, because otherwise it's just unacceptable to the devs, like tripling build times or something like that. It seems like it's a problem that actually really needs to be solved. More of a comment than a question, I guess.
Yeah, I think that there's some work that could be done in the Maven community to speed that up.
Yeah, like I mean, you can multi-thread modules, but you can't multi-thread, as far as I know, getting the dependencies.
Yeah. I mean, it does multi-thread. It will download multiple dependencies at the same time if it can identify that, but as it's walking the dependency tree, it'll kind of serially.
Okay, I haven't experienced that, at least in terms of the time it takes versus just reading it off the network volume.
Yeah. Cool. Anybody else? All right. Oh. What's your opinion on boycott Docker? I don't have an opinion on boycott.docker.org. So I mean, like, I don't know. Docker's a pretty good piece of technology. I've contributed back to the project a little myself, so I've read through the code, and it did frustrate me a little bit the first time I read through it. So I don't know if it's the best piece of software, but I don't have a strong opinion on that. Cool. Well, thank you. Holly?